In this video, we will discuss some important integrals that involve the function box x. In one of my earlier videos, I have explained the function box x, its graph, domain, and range. So now let us discuss some integrals. First, we will discuss the integral 0 to 1.5. This is definite integral box of x square dx. How to calculate this integral, this definite integral? Now first what I'll do is I'll divide this interval 0 to 1.5 into three subparts. Now what are the subparts? First 0 to 1 box x square dx. Then this is important, 1 to root 2. You might think that we should go from 1 to 1.5. No, we will see. If I see the number line here, then this is say 0, this is 1, and this is say 2. So 1.5 is somewhere here. 1.5 is somewhere here, right? And root 2 is 1.4 something. So root 2 is somewhere just on the left of this arrow. So somewhere here. So we are breaking the interval like this. One I'm taking from 0 to 1. One I'm taking from 1 to root 2. The other is root 2 to 1.5. Now why I am breaking it like this, you will soon understand when I explain the next step. So let's complete this. So 1 to root 2 box x square dx. Plus root 2 to 1.5 box x square dx. Okay. Now let us see what are the values of box x square in each of these intervals. Okay. Now I'll explain each of these separately here. For example, now one very important thing you have to note here, that is this 0, this 1, they are actually values for x, values or limits, whatever you say, limits for x, not x square. Whereas the function that we have here inside the box is x square, not x. That makes all the difference to this sum. So suppose if I want to explain the first part like this, I will explain it like this. Here you see x lies between 0 and 1. So 0 less or equal to x less than 1. This will imply that x square will lie between 0 and 1, right? So what will happen? From 0 to 1 interval, in this interval, box x square, the value of box x square, that is the greatest integer less or equal to box x square. So that you can see this interval, in this interval, that value is, so let me write it down, box x square will take the value 0, because x square, you treat this as a unit. X square lies between 0 to 1, including 0, excluding 1. So box x square will be 0. So the first part of the integral becomes 0 to 1, 0 dx. Box x square is 0. Now let's see what happens to the second part. Second part is 1 to root 2. Now you see I am explaining it here. So what is happening? X lies between 1 and root 2. So 1 less or equal to x less than 2. So that means x square will lie between, root 2. So x square will lie between 1 and 2. So if x square lies between 1 and 2, then box x square, the value will be 1. This is precisely the reason why we have divided it into 1 to root 2. So that if x falls between 1 to root 2, x square will automatically fall between 1 to 2. And that is exactly the next interval that we want after 0 to 1. So in this interval, box x square takes the value 1. So 1 into dx. Now let's see what happens to the third portion. Let me explain here. Here the limits of x are root 2 and 1/5. That means root 2 less or equal to x less than 1.5. So that means if you square it, then 2 less or equal to x square less than 1.5 square. So that is 2.25. So that means box x square will take the value 2. So we can now replace box x square here by 2. So this is root 2 to 1.5 and box x square is 2 dx. So now you see why we divided the given interval 0 to 1.5 in this manner. So now it's easy to calculate. If you now calculate it, then you will get this is 0. So this is integration of dx is x and the limits are 1 to root 2 and this is 2x. The limits are from root 2 to 1.5. So if you calculate the value, it will come 2 minus root 2. So this is the answer. So this is the first integral that we calculated. Now we will calculate a slight variation of the same type of integral. So this time we want to calculate 0 to 1.5, not only box x square, but the product of two functions x and box x square dx. We want to calculate this in. So we will actually proceed similarly, just like we did in the previous case. We will again divide it into 3 intervals. So this time it is 0 to 1 x box x square dx plus 1 to root 2 x box x square dx plus root 2 to 1.5 x box x square dx. So now let us put the different values. Okay. Now the first part 0 to 1. Now you know between 0 to 1 box x square is 0. So this portion becomes 0. So x into 0. So that is again 0 dx. So this portion vanishes. Now the next one 1 to root 2. Now 1 to root 2, you have seen just now, if x lies between 1 to root 2, then x square lies between 1 to 2. So value of box x square is 1. So this time it becomes x into 1 dx. And the third one, root 2 to 1.5, you have seen that the previous sum, the value of box x square is 2. So this becomes x into 2 dx. So now you have all the 3 portions. So let's integrate. So this portion vanishes. This becomes x square by 2. Limits are from 1 to root 2 plus this is 2x square by 2. So that is x square from root 2 to 1.5. So now if we calculate the value, this becomes half 2 minus 1 plus 2.25 minus 2. So finally you get 0.75 is the answer. So you see these two integrals are very similar. So in the next video, I will show how to calculate some more integrals that involve the function box x. If you like this video, then please subscribe.